So in this video, I'm going to teach you about state symbols that are used when you are writing a chemical equation. So substances that we deal with in a chemical equation may simply be in solid state. So we simply use a small letter S. Other substances may be in liquid state. We use small letter L. And other substances that we may deal with may simply be in gas form, or they may tell you that it is actually in vapor. So when it is in gas form or in vapor, it simply means that we are going to be using small letter G. Then the other one that we can talk about is when a substance is in aqueous solution. So small a and small q there, that's what we are going to be using. Now remember, when they say that something is in aqueous, it simply means that the substance has actually been dissolved in water, and that is why we are simply saying that it is in aqueous solution. Let's take, for example, you have a reaction where magnesium is reacting with oxygen to produce what we are calling as being magnesium oxide. So how can you apply these state symbols that we have? Of course, magnesium, all metals in this case except mercury at RTP, you are going to find that all metals are simply in solid state, and therefore that is what I'm going to put up there. Oxygen is simply a gas, and of course that is going to be small letter G. Then magnesium oxide there, that substance that is going to be produced is going to be in solid form. Now possibly the question that you may have is, how can you tell whether this substance is actually in solid, in liquid, in gaseous, or in aqueous form? Is there a magic that can help you to do that? The answer is no, but you need to know what we are calling as being the solubility rules. So these solubility rules will actually help you or guide you as to know which substance to some extent is actually in solid, in liquid, and so on, and so forth. So you need to remember that. So let me just give you a solubility table that will actually guide you in your discussion as you try to embark on writing a chemical equation with state symbols. So what I'm going to do is that I'm going to demarcate my table there, and this side I'm going to have what I'm calling as being soluble. I'm going to have soluble salts or substances that are soluble. Then this side I'm also going to have insoluble salts that we can have. So this is called a solubility table. It will help you just to have an idea of some state symbols that you can use. For example, what I can simply say is that all sodium, lithium, or sodium, lithium, potassium, and also ammonium salts are simply going to be soluble. So that is what you need to remember. So maybe let me just try to eliminate that, but if anything is in sodium, lithium, and potassium, then it simply means that it is actually going to be soluble. So that's what you need to remember. In this case, again, you need to remember that all nitrates, anything that contains a nitrate, NO3 ion in it, that contains a nitrate ion, is actually soluble. So you need to know. So if it is soluble, it simply means that for all those substances that are soluble, we are going to be using the word aqueous, because they are actually soluble. For those that are insoluble, we are going to be using the state symbol solid there. Another thing that you need to remember is that all chlorides, those that contain the chlorine ion, are actually soluble, but there are a few exceptions that are insoluble. For example, we can talk about silver chloride, we can talk about lead 2 chloride. These are actually considered insoluble, but the rest of the chlorides that we are going to have are going to be soluble, and therefore we are going to be using aqueous. Another aspect that you need to remember is that all sulfates, those that have the sulfate ion, are simply soluble, but there's few exceptions that we have for example, calcium sulfate, which is sparingly soluble. Then we can talk about barium sulfate. We can also talk about lead 2 sulfate. All these are considered to be insoluble, and hence you need to remember that. Then another thing that I can simply tell you is that when it comes to all oxides, you're going to find that those that contain the oxygen ion, they are actually insoluble. That's what we mean. So all oxides, the only exception that we have are simply oxides that contain sodium, potassium, maybe calcium in this case, and we can simply talk about ammonium. So you're going to find that all of the oxides are going to be insoluble. So we can eliminate that, because in most cases it is not always going to be the case. But if they contain sodium, potassium, and ammonium, oxides containing these are actually soluble. But those that are containing oxides, except from these ones, we consider them to be actually insoluble. Well, the table can go on. I can still give you some more. I can simply give you some more. Is that when it comes to all carbonates, so all carbonates, so again, all carbonates, those that contain the carbonate ion, they are actually insoluble. Except, so the only exception of carbonates that are going to be insoluble in this case is those that are containing sodium, those that are containing potassium, and those that are containing ammonium ion. For example, you have sodium carbonate, sodium carbonate. You can actually talk about potassium carbonate, and you can talk about ammonium carbonate. So those are simply going to be soluble. So those are some of the concepts that you need to remember when it comes to state symbols used in chemical equation. But of course, as you go on, you'll be able to to know this, and actually come up with the state symbol of a particular substance that you have been given in chemistry.